Hi, welcome to the video demonstration of multi-class classifier naive Bayes algorithm. And in this project, again, we are going to classify iris flowers, which basically has three classes. And we have the training data set here, iris data.csv. In this data set, we have 5 columns. And we are going to use sepal length, sepal width, petal width to classify the iris flowers into 3 classes. So before we begin, let's look at the dependencies here. And we have NuGet.org and the package, and we have Microsoft.ml package 1.1.0. So let's update the package. So we go to NuGet.org and we type ML for machine learning, and we are going to update the Microsoft.ml because the latest version is 1.2, and you have seen that before. So we're going to update the Microsoft.ml package. Let's check the package to make sure that it's been updated. Yes, the package has been updated. So let's go back to program.cs. So the next step is going to be to add 2 classes, iris input data model class and iris output data model class. These are the same classes you have seen before, and in this case we have iris input data model, and before that we have some libraries that are imported, and most important here is using Microsoft.ml.data library. And iris input data model has 5 properties: public float sepal length, public float sepal width, public float petal length, public float petal width, and public string label. And we have load column 0, that's the first column of the input data table. Load column 1, there's the second column of the input data table. Load column 2, there's third column of the input data table. And load column 3 is the fourth column of the input data table, and load column 4 is the 5th column of the input data table. By input data table, I mean the input data set iris-data.csv file. So let's look at the next file called iris output data model class. In this one, we have only one property, public string predicted label. So it will be used for predicting the label. So one serves as the input data model to the trained machine learning model, and the other one is the output of the trained machine learning model. So let's look at the iris data.csv. Again, it has 5 columns: sepal length, sepal width, petal length, petal width, and the class of iris flowers. And you must import this file as part of your solution, and in the usual way. And so let's look. The other thing that we have to make sure is that the copy always is selected as copy to output directory. So let's look at the program.cs file here. We have imported using system.io, and we have the usual Microsoft.ml packages, Microsoft.ml.data, ml.trainers, ml.transforms, and using static Microsoft.ml.data operations catalog. So after importing these libraries, we go into class program. Step 1, we declare the path to save the trained machine learning model. So we have static read-only string model path, path.combine environment.current directory model.zip. So that's the path to save the trained machine learning model. And in the main method, inside the main method, we have step 2 ML context, and we instantiate that using new ML context. Step 3, we define the training data view object of type iDataView using ML context data.load from text file, iris input data model, path iris-data.csv has header false and separator character comma. Step 4, we create the data preparation pipeline using ML context.transforms. And in this case, we first define or declare features column name features, and then we have data preparation pipeline object we use ML context.transforms.conversion.map value to key label. Then we use .append ML context.transforms concatenate features column name, sepal length, sepal width, petal length, petal width. So these four features columns will be concatenated into the features column name here. And then we use append cache checkpoint, which is basically used for smaller data sets, but please do not use that for large data set as it might affect performance. Step 5, we create the naive Bayes multi-class trainer. We use data preparation pipeline object from step 4 here, and use the .append method and pass ML context.multi-class classification .trainers.naive Bayes, and then we pass label column name label and feature column name features column name we defined here as part of step 4. Step 6, we split the training data set into 80% for training and 20% for testing. So we have train test data ML context.data.train test split, training data view, and test fraction 0.2. Step 7, we create the machine learning model using naive Bayes multi-class trainer that we defined in step 5 here. Naive Bayes multi-class trainer.fit, and we pass train test data.train set. Step 8, we create the metrics to assess the performance of the trained machine learning model. So we use var matrix ML context.multi-class classification.evaluate, and we pass model.transform train test data.test set. Step 9, we write some console.writeline statements to send the output to the console and to look at the performance metrics. So first we have confusion metrics, macro accuracy, micro accuracy, log loss reduction, top K accuracy, and top K prediction count. And then we define a new iris flower as iris input data model, and we specify the sepal length, sepal width, petal length, petal width. You can vary these features, sepal length, sepal width, petal length, petal width, and see how the classification changes when we use that flower to predict. Next, we create the predictor ML context.model.create prediction engine. We pass iris input data model, iris output data model, and the model that we created trained as our machine learning model. Step 12, we have predicted a class of flower, predictor.predict, and we pass prediction data that we created in step 10. And then we have the console.writeline statement where we have predicted a class of the flower. We have predicted a class of flower dot predicted labels dot to string. Step 14, we specify the file stream object, passing the model path, file mode, file access, and file share arguments, and then we use ML context.model.save to save the trained machine learning model. Having done that, let's run the program and see the output. So the output is here, and we are looking at a naive Bayes algorithm, and we can see that the output for this specific multi-class classifier, which uses naive Bayes algorithm, we have a macro accuracy of 33% and micro accuracy of 28%. And you can see that the precision and recall are also not very good. So it basically tells us that as a multi-class classifier for this specific data set, the naive Bayes classifier is not performing as well as the other algorithms, multi-class algorithms we have looked at in other chapters. So again, this is part of machine learning. You use different algorithms to see which algorithm performs best for your data set. And that's why in this book we have created multiple chapters using the same data set, just to demonstrate that how the performance of the algorithms vary, even though we are keeping the data set exactly the same, just to give an idea that each algorithm has an impact on how well the machine learning model might perform given a data set. Thanks so much for watching this video.